Hey everyone, Nick Dearbertis here teaching you financial modeling. Today we're going to be solving the lab exercise on generating and visualizing continuous random numbers in Python. So we already completed this exercise for Excel, but now we are doing the same thing in Python. So generating numbers from uniform distribution, from a normal distribution, and visualizing the outputs of both of those and calculating the mean and standard deviation of each of those, recalculating it a number of times, and noting the differences between using 10 iterations and 1000 iterations. So let's jump over to a fresh Jupyter notebook so that we can work this out. So we want to work out this logic to generate random numbers. The first thing we're going to need is to import the random module. So then we can recall that that random.random gets us that between 0 and 1. So that's all we need to do for that one. And we have random.normalvariate, which we can give a mean and a standard deviation to get the normal distribution random numbers. So I'm going to set up some initial inputs here, just for now, just as individual variables. So I'm going to have n, how many random numbers we're going to generate. I'm going to have the mean as 0.5, and I'm going to have the standard deviation as 10. So the first thing that we want to do is generate 10 random uniform distribution numbers between 0 and 1. So we can just put this in a list comprehension to do that. And there we have 10 different random numbers. And similarly for the random normal variate, we can do that with a list comprehension as well. It's going to be with the mean and the standard deviation, again, in the range of n. So there we have our numbers generated for us. So then we need to visualize these and produce some summary statistics. So we know that data frames are perfect for doing both of those things. So let's go ahead and also import pandas as PD so that we can form data frames out of these. So then we can set it up so that we're going to create our initial data frame, and then df uniform is going to be equal to what we had calculated there, and df normal is going to be equal to what we had calculated here. And then we get a data frame with the 10 different values of uniform and normal distribution random numbers. This is a nice discrete step in the process. We got the random numbers, and then we want to visualize and take summary statistics after that. So I'm going to go ahead and wrap this up in a function. So this can be, let's just say random df, or let's do get random df. And so that is going to take the n, the mean, and the standard deviation. And then we're going to return the data frame at the end. So now we can call that with the n, the mean, and the standard deviation, and we get the same result. So next we want to then visualize this and get the summary statistics. So here I'm going to go back to df is equal to get random df. We have that data frame. Of course, we can do df.mean to look at the mean, and we can do df.std to look at the standard deviation. So we have those that we can do, and then we can also visualize this. So we can take the uniform and we can plot that as a histogram. And we can do the same thing for the normal as well. So then we can put all of this into a function as well. This is kind of all of our analysis, put that into a single function. So we can say this is our random analysis. We pass it the data frame, and we're going to do all of these things. The histogram of the uniform, the histogram of the normal, and the standard deviation and the mean. So I'm going to put all those in there, and then we'll see some other adjustments that we're going to need to make for this to work appropriately. So we call random analysis on the data frame, and now we see not quite what we had expected to see. We see both of these getting combined into the same plot. We also don't see the standard deviation or the mean getting shown. So there's a couple extra steps here. So we can, this is where we have to bring in a little bit of matplotlib, matplotlib.pyplot as plt, and we can do plt.show after each, and that should be able to separate out these two graphs. So now we see them separately because that's saying show everything that we've plotted, kind of clear it out, then do the new plot and show everything again so the two plots don't affect each other. But we still don't have the standard deviation and the mean. So all we have to do for those is print them to get them to show up. So add the print statements around those. And now we can see those statistics coming up here. Though the one thing that's still kind of missing here is labels of what's going on. So I think we can pass the title in here, give that a try. Yeah, that works. So you can pass the title in here, uniform and normal. So now those are clear. And we can also print a header for each of these standard deviations. Print means. And now, and let me just throw a new line on the end of each of these. You could also do a separate just print of an empty string to achieve the same thing. And let me do that before this one to separate them. And now this is looking pretty good. It's clear what are the standard deviations, what are the means, and what are the plots for the uniform and the normal. So then I'm going to these together, and I'm going to create one more function, which is going to be random df and analyze. So that's just going to put these two steps together. So I'm going to take this and put it in there, and then going to call the random analysis on the data frame and then return the data frame at the end. That means that now we can do random df and analyze with whatever we want, and it's going to create, show all that analysis, and then also give us that data frame that we could do additional things with. So now this is all kind of together into one function. So now we can, let's just go down to here, and we can run this a couple of times. So this is with the n equals 10 case. And you can see, kind of the same thing that we saw in Excel, that things are very blocky. We're not getting a very good view of what the distributions actually are. And when we look at the summary statistics, they are jumping around quite a bit um, with only 10 observations. But then if we switch this out and we do 1,000 observations, all of a sudden the uniform looks pretty uniform, the normal looks pretty normal, and the standard deviation here is close to the theoretical standard deviation. The mean here is close to the theoretical mean, and that's going to happen no matter how many times we run this. It's always going to come up fairly close on all those because we're using a larger number of observations. We can even take this even much further here to 100,000 observations. You can see it's almost completely flat on the uniform. The normal looks very normal. And now we're like very, very close to the standard deviation and mean that we had used to create this. So that is the lab exercise in Python. So thanks for listening and see you next time.